Good day, everyone, and our honorable judges. Today, we are excited to introduce a groundbreaking solution to one of urban living's most persistent challenge: parking efficiency. Our team of multidisciplinary engineers have collaborated to design the multifunctional smart Valet, a system to transform how cities manage parking and logistics. Urban parking isn't just a minor inconveniences; it's a crisis with cascading impacts. First, high vehicle densities force drivers into prolonged searching for parking. This is efficient. Imagine reclaiming that time and reducing congestion instantly would definitely help the human development. Next, outdated parking system lead to a poor space utilization. Traditional lots operate at just 60% of its capacity while drivers circle endlessly. That isn't just frustrating, it is costly, and also business lost revenue from customers, and also cities face economic losses from inefficient land use. Not just the impact to the economy, and furthermore it's about the environment. The time waste, the higher fuel consumption, and also the increase of carbon emission definitely hurts our mother nature.
So now let's look at our solution overview to tackle this problem. Introducing the Smart Valet system, an autonomous parking system and warehouse logistics system. Firstly, the user parks the vehicle in a garage and registers the user information. Next, vehicle identification via license plate scanning is done using CCTV and machine learning system. Two smart valets are used for car lifting. Then the shortest path planning is done using the Jing Square algorithm. The Jing Square algorithm finds the shortest path in a weighted graph of the car park by setting the source distance to 0 and others to infinity. Then it selects the nearest unvisited node, updates the neighbor node distances if shorter paths exist, and marks it as visited. This is repeated until all nodes are processed, ensuring that the most efficient pathway is determined. Auto calculation of parking duration and fees is also carried out after the car is being parked. Lastly, Smart Valet retrieves the car to garage using the store card plate number when it is called again. Not only that, the Smart Valet can also be used to lift wood pallets using the same lifting mechanism. Now, let's take a closer look at our Smart Valet system. For this case study challenge, we use the Myvi Standard G as our reference vehicle and a standard wooden pallet to determine the optimal robot dimensions for our Smart Valet. Firstly, the 4-bar linkage gripping mechanism. Each gripper swings outward in a 90-degree circular motion powered by a motor-driven gear system with a 2:1 tooth ratio to ensure smooth and efficient operation. Next, the rack and pinion mechanism. This mechanism is integrated into the gripping mechanism for controlled horizontal movement, ensuring a secure and precise camping action around the vehicle tires or wooden pallets. Next, the lifting system. The Smart Valet's scissor lift mechanism enables Z-axis elevation while maintaining structural integrity and preventing buckling action. Last but not least, the lower base with wheel system. For locomotion, the robot requires omnidirectional movements using mechanism wheels to allow straight movement, diagonal movement, and sideways movements. To withstand high loads and continuous operation, the system is constructed from hardened steel, offering exceptional durability and minimal deformation over time. All calculation can be referred in our proposal. For our robot perception system, we use both computer vision and LiDAR Arduino system. With assistance of YOLO V8, our trained AI model can help to detect vacancies in parking lot, identify car plate number, and recognize warehouse materials. While for the LiDAR system, it prevents collision between valets, vehicles, or warehouse items and detect vehicle wheels to enable precision clamping, lifting, and transportation of items. We also carry out a simulation of dynamic load capacity to prevent any structural failure. As for the market feasibility, our Smart Valet system can be used by city governments and municipalities, shopping malls and commercial centers, airports and transportation hubs, real estate developers and smart communities, hospitals and universities, and lastly, private parking operators and valet services. Through this project, we hope to achieve a few outcomes and benefits. Firstly, to reduce carbon emissions, Smart Valet system can save the time and fuel needed for parking to reduce greenhouse gas emission. Not only that, it also saves users time and make it convenient for them to park their vehicles smoothly. The Smart Valet system also helps to smooth traffic flow and reduce traffic congestion caused by inefficient parking system. Lastly, this project enhances warehouse and logistics efficiency by reducing the reliance on manual labor and optimizing the storage of items. That's all from our team. Thank you.